Okay, so today we want to understand how to multiply fractions. The rule is simple. The rule says multiplying fractions is no problem, top times top and bottom times bottom. So technically speaking, we're supposed to do 4 times 10 times 15. 4 times 10 is 40, and 40 times 15 I know is 600. Okay, then I want to do 15 times 24 times 3. Well, I know 15 times 3 is 45, and then 45 times 24, I have to work on my side of my paper, and I would get 1,080. Okay, so the rule of multiplying is real simple. You go straight across, and you multiply. But now, this fraction is unacceptable because the fraction bar means division. And now we got to divide. We got to reduce these very large fractions. Well, I know if both numbers end in a digit 0, I can divide by 10. So 600 divided by 10 leaves me 60. And 1,080 divided by 10 leaves me 108. But that's still not reduced. 60 over 108 is still a very large number. We know these are both even, so we probably could divide them by 2. So if we divide this in 2 in half, we'd have 30. And if we divide 108 in half, we get 54. All right? We're still not reduced. They're still even. So 30 and 54 must have a factor in common. And if you know your times tables, okay, I think I can divide those both by 3. So 30 divided by 3 is 10. 54 divided by 3, well, 3 goes into 5 once with 2 left over. 3 goes into 24 8 times. Well, now I have 10 18ths. Those are still even, so I need to divide those by 2. 10 divided by 2 is 5. 18 divided by 2 is 9. So there is your final product. Now, if you look, think about this. We're not using calculators. So to multiply this out, it's going to take work on paper. And then divide it out. Look at all the steps, because like you, I did not know the greatest common factor off the top of my head. What happens if I told you there was a quicker way to do this? So let's write the expression again. 4 15ths times 10 24ths times 5 thirds. 15 thirds. The dots mean multiplication, the bars mean division. Because multiplication and division are equal, mom does not go before dad. We could do multiplication and division in either order. And that's where you all learned about canceling. Now, the problem with canceling is you have to be organized. So this is the method I go about. I start with the first numerator and I say, what number in the denominator can I divide with 4? Well, 4 and 24 will divide into each other. 4 divided by 4 is 1. 24 divided by 4 is 6. I'm going to go to the next numerator, 10. Who can I simplify or reduce 10 with? Well, I can do 10 and 15. They have a common factor of 5. I can do 10 and 6. They have a common factor of 2. It doesn't matter. But I believe most of you will do the 10 and 15. So if I divide 10 by 5, I get 2. If I divide 15 by 5, I get 3. So now I'll go to the next numerator, 15. Who in the denominator can I divide 15 with? Well, 15 and 3 have a common factor of 3. 15 and 6 have a common factor of 3. 15 and 3 have a common factor of 3. I can use any of them. I'm going to use this fraction right here, up and down, just to prove to you, you don't have to cancel going diagonally. If I divide 15 by 3, I get 5. And if I divide 3 by 3, I get 1. Everybody with me? Now look closely. Look at your numerators now and see, did you actually reduce or can you keep reducing some more? Well, 1 is in lowest terms. Can't do anything with that. 2, though, can divide. 2 can reduce with 6, right? 2 divided by 2 is 1. 6 divided by 2 is 3. Okay, now I have a 5. Well, 5 and 3 do not have a common factor other than 1. 5 and 3 do not have a common factor other than 1. So now I'm done doing all my division, all my reducing, all my canceling. Now the rule is to still multiply across. But look what you have left to multiply. You have 1 times 5. And in the denominator you have 3 times 1. So in the numerator you have 5, and the denominator you have 9. Isn't that the same product? So you tell me, what was easier? Multiplying first and making two really large numbers and then trying to reduce them, or starting here and reducing, doing the division first, and ending up with small numbers to multiply? I believe this is the quicker method. So what's going to happen in algebra is you're never going to see anybody multiply across first. The first thing we're going to do is reduce, cancel, divide, whatever you want to call it, and then we'll take what's left and multiply to get our product.